Assalamualaikum. My name is MJII-Amar. So I'm going to explain a little bit about job sheet 3. It is about RC circuit and the analysis of the RC circuit. So in this job sheet, we are going to determine the phase angle in a series of RC circuit to measure and calculate the voltage drop in RC circuit. And we are going to also calculate the impedance and phase angle of the RC circuit. So the equipment that we are going to use is the multimeter, function generator, oscilloscope, and the B3000 watt. And also the starting lead. So for the first experiment, series in RC circuit, we are going to calculate impedance using three methods. First, the practical one. Second one is from the formula set 2R, and the third one, the formula R2 plus XT power of 2. So from these three methods, we are going to compare the results to get the closest one to each for each result. We are going to use multimeter to measure the current, and the function generator to adjust the amplitude and frequency, and for oscilloscope to see the phase angle for to VC and VR. So as you can see here, this is the result I get from the oscilloscope. So I think that's all for series in RC circuit. So I'm going to explain briefly about the procedure for the series RC circuit. So basically, we're going to calculate voltage drop in here and also in here, resistor and capacitor. So we're going to need to adjust the multimeter position and the connecting junction position, and also how to use this function generator and multimeter to measure what we are needed to measure. So we also need to use the oscilloscope to see the phase angle, which one is leading, which one is lagging. So I think that's all for RC series circuit. Okay, so for parallel RC circuit, we are going to measure I from IR and IC. So this is the result for parallel RC circuit. The procedure I'm going to explain briefly. First, we're going to set the function generator in 1.6 kHz frequency, and we are going to find the I total by adjusting the IR and IC from the provided. So if you want to get 2 milliampere, we're going to set the amplitude to 2.27 volt and 1.55 kilohertz for capacitor current. And then from the multimeter, we just connect the shorting links and the multimeter, the COM lead, and the red one, we get the I total. The question is, why do we need to adjust the voltage supply to find the resistor current? This is due to the Ohm's law. If the voltage increases, the resistor increases. So we get the desired current. So by changing the voltage supply, you can control and measure the current through the resistor, because it follows a linear relationship. Okay, the next one, IC. Why do we need to change the frequency? As we know, the formula for XC equals to 1 over 2 pi FC. So from the formula, higher frequency will lead to lower reactance, lower capacitance, and lower frequencies will lead to a higher capacitance. So by adjusting the frequency, we can see how the current through the capacitor is affected. So that is why we need to adjust voltage supply or resistor, and adjust the capacitance for the current through the capacitance, so that we can find the findings. Okay, so the last one is about phasor diagram. This one is quite easy because it just use theorem Pythagoras. With the IR, to find the supply current, we use theorem Pythagoras. IR is in phase with voltage supply. Meanwhile, current leads voltage supply by 53.13 degree. So the conclusion for the job sheet, I can say that in series RC, we lags voltage lags or leads current based on phase angle between resistor and capacitor components. Meanwhile, in RC parallel, I total is combination of in phase of resistor current and capacitor current. So this is show how different resistors and capacitors behave in RC circuit, especially how voltage and currents are phase shifted due to the capacitive reactor. So this is all because of capacitive reactance. I think this is all for job sheet 3, the RC circuit. That's all from me. Thank you.